Hello everyone, welcome to my channel. Uh, this is an educational channel and we generally look at inspiring and useful theories of everything that people can learn. Might not be that easy, but we can learn them and they can have a positive effect on our life in many different ways. And try to share some of the best ones that I've studied in, I guess, the last 30 years or something. And today is the video, 298th video that we've done on Dewey B. Larson's Reciprocal System of Theory. Dewey B. Larson was an engineer who lived in the 20th century and was back in the 20s and 30s, was trying to make some contributions to understanding the interatomic distance and other properties of matter having to do with chemistry, and stumbled across some ideas came into his head about maybe trying to make a few assumptions to help him solve a couple equations, and he eventually started applying those things more broadly. Long period of trial and error, and took him until about the late 1950s when he put out his two fundamental postulates. And then from there, he took his postulates and he derived a theoretical universe about how, okay, if my postulates are correct, this is how the universe works. And his theoretical universe turned out to match the legacy scientist universe in about 90% of the cases. And there's other 10%. Turned out that Larson's version was actually better than the version that the legacy scientists had. And so he ended up writing a lot of books on chemistry and physics and astronomy, also on metaphysics, including philosophy, religion, and psychology, also on economics, and a lot of things having to do with psychic and occult, somewhat occult phenomena, dream interpretation, ESP, clairvoyance. And the basic idea behind Larson's reciprocal system is that we live in a universe made entirely out of motion. The universe is not made out of matter, it's not made out of energy, it's made out of motion. Matter and energy are two varieties of motion. And motion is the relationship between space and time. That sets up a generalized reciprocal relationship between space and time. Just like 3 1/3 are reciprocals, 4 1/4, 3/2 and 2/3 are all reciprocals of each other. Space and time are reciprocals in that they have no independent existence. They only exist together in motion. And they both have identical qualities, which manifest at different times. But in his first postulate, Larson identifies 3 important qualities that they have. One is coordinateness. Time and space both come in 3 dimensions: coordinate space and coordinate time. We generally recognize the existence of coordinate space, not so much with coordinate time. And space and time both have their progressing or scalar aspects. Now, a scalar motion, is a motion that has a magnitude but has no particular direction. We generally recognize this in a clock with time. The clock is always getting later and later and later and later, but in no specific direction. That's the progression of time. And we recognize that in general, but we do not so much recognize the progression of space. The space is always getting farther and farther and farther apart. And that can be envisioned using a balloon with some dots on it. Blow up the balloon, all of the dots are moving away from each other. This is the model that you might use for describing the Hubble telescope's discoveries of the fact that all of the distant galaxies are moving away from each other. That is the progression of space. And that's something we're not very familiar with. And then space and time also have their quantized aspect, meaning that space and time only come in chunks. There is a minimum unit of space and a minimum unit of time, below which you do not have space and you do not have time. You need to have a full unit of space. And if you don't have a full unit, then you don't have anything. And then you need to have 2 full units to have 2 units. If you only have 1.3 units, then you only have 1 unit. And the same is true of time. Now, the minimum unit is very, very small, microscopic, darn near instantaneous for space and time, but they do exist. They are quantized. And if you have exactly 1 unit of space in 1 unit of time, you have the speed of light, which is what Larson calls the reference point, the 0 point, the state of rest, the background, ether, origin. And it makes sense. If you have a universe of motion, then that means that motion is the first thing that you have. And you have to be able to conceive of motion without anything moving. And so where the legacy physicists are making their measurements from 0, and they are making their measurements additively, +1, +2, +3, -1, -2, -3. In the reciprocal system, the additions are made multiplicatively, and Larson refers to this as displacement. And you start with 1, not 0. 1 is the speed of light. Larson calls it unit speed. 1 over 1 equals 1. 1 unit of space and 1 unit of time equals unit speed, the speed of light. And if you're going faster than the speed of light, then you move over to 2, 3, and 4. If you're going slower than the speed of light, then you move over to 1/2, 1/3, and 1/4. So they multiply to make 1, as opposed to adding to make 0. And that also means that half of the universe is moving faster than the speed of light, as well as the half that's moving slower than the speed of light that we're familiar with. Larson refers to the latter as the material sector, and this, for Einstein and the legacy scientists, is the whole universe. Einstein said that the speed of light is the maximum speed of the universe. But for Larson, there's an entire other half of the universe that he calls the cosmic sector that's moving faster than the speed of light. And this sector is virtually unknown by legacy scientists, but they could bridge the gap very quickly because of the reciprocal postulate. So whatever is going on in the material sector that the legacy scientists know about, the exact same thing is going on in the cosmic sector by the reciprocal relation, except that you have to reverse the roles of space and time. So in the material sector, you have relations that are based on coordinate space, 3 dimensions of space, and clock time, progressing time. Time's always getting later and later and later. In the cosmic sector, you have the reverse, where you have coordinate time, 3 dimensions of time, and clock space. Space is always getting farther and farther and farther apart. So, you know, they are basically twin universes, inverse mirror images, and you can extrapolate from one to the other, and you can move from one to the other by simply crossing the speed of light, which, you know, maybe isn't as simple as just saying it. But Larson started from there. Then he wrote up his books from the deduction from that first postulate, and also the second postulate that really just has to do with math and geometry. And then he eventually died in 1990 after putting out maybe 15 books and about 50 articles, a lot of talks and so on, other presentations. And he had built up somewhat of a following that also had been writing articles in a journal called Reciprocity. And some of these other writers came to the fore at this point, among them Dr. KVK Nehru, who we're going to be hearing from today. I believe this is episode 5 that we've done on his article that is called the Time-Space, or the Space-Time Universe. And he talks about various aspects of the reciprocal system and identifies them as various outstanding achievements of the reciprocal system. So we've gone through about the first 5 of those outstanding achievements. And so we're going to start right after that. So if you want to go back and listen to the first few, the 4 episodes before this, then you will be basically caught up on this article. The new look at gravity at once clarifies a puzzle about its nature which has, so far, not been explained by science, that it cannot be screened off, unlike other forces like electricity or magnetism. The explanation is that gravitational motion is not an interaction between one mass and another. It is the inherent motion of the individual atom toward all other space-time units, and there is nothing that is propagated that could be screened off. Now again, use your balloon analogy here. When you blow up the balloon, all of the dots are moving away from each other. That is what Larson calls the progression of the natural reference system, if it's at the speed of light. Now, when you suck in the balloon, all of the particles are moving toward each other. That is more of a model of gravitation. All of the particles are moving toward each other, but each one has an inherent motion. So there's not an interaction between one, like Nehru says right here. Gravitational motion is not an interaction between one mass and another. It is the inherent motion of the individual atoms toward all other space-time units. So there is nothing that is propagated or could be screened off. At this juncture, it may be of interest to see how the mass-energy quantum of Einstein arises. In the reciprocal system, mass is three-dimensional inverse speed. The coordinates of matter are time to the third power over space to the third power. All scientific quantities have can be expressed exclusively in terms of time over space or space over time with various dimensions. So matter is time to the third power over space to the third power. You know, your basic motion speed is space over time. The car is moving 10 miles an hour. Then you have acceleration. The falling rock is moving at 9.8 meters per second squared. But then you also have, things such as energy. Energy is time over space. It took me 5 hours to move that thing 20 feet. Or you also have force. Force is time over space to the second power. Pressure is time over space to the fourth power. And so on and so forth. So, in the reciprocal system, mass or inertia is three-dimensional inverse speed, while momentum and energy are respectively two- and one-dimensional inverse speeds. Okay, so mass is time to the third power over space to the third power. Momentum is time to the second power over space to the second power. And energy is time over space. It is already pointed out that c, the speed of light, has been identified as the natural unit of speed in the reciprocal system. As such, one natural unit, that's space over time, as such, one natural unit of inverse speed becomes 1 over c in the one-dimensional case, and 1 over c to the third power in the three-dimensional case. Thus, m units of mass and e units of energy, when expressed in the natural units, are respectively m over the quantity 1 over c to the second power, and e over the quantity 1 over c. We find that quantities expressed in the natural units can be equated directly, and that the constants of nature, like, for example, the gravitational constant or Planck's constant, are actually conversion coefficients whose numerical magnitudes are the result of choosing conventional units in an arbitrary manner. Thus, we find that E equals 1 over C equals M over, E over the quantity 1 over C equals M over the quantity 1 over C to the third power, which can be rewritten as E equals MC squared. You can also just substitute the units there. E equals T over S. M equals T to the third power over S to the third power. And C, speed squared, is S to the second power over T to the second power. And so the equation balances out. If you multiply them together, the M and the C squared. Another remarkable insight the reciprocal system gives into the nature of gravity, which no scientist hitherto has ever suspected, is that gravitation does not always manifest as attraction. It also manifests as repulsion under certain circumstances. No doubt, students of occult literature, however, do find this intriguing concept enunciated at more than one place in The Secret Doctrine of Madame Blavatsky. Now, this has to do we talked about the boundary between the two sectors of the universe, the material sector and the cosmic sector. They're divided by the unit speed boundary, so the speed of light. And when you cross that boundary, the rules invert. So you go from coordinate space and clock time to coordinate time and clock space. Now, within each one of those sectors, there is also what you call a unit boundary, a unit of space in the material sector and a unit of time in the cosmic sector. And again, according to the discrete unit postulate, if you do not have a unit of space, then you do not have space. And since the universe is made out of motion, and motion is the relationship between space and time, everything has got to be made out of either space or time or both. And so if you don't have space, that means that you only have time. So Larson refers to this region of action that is less than 1 unit of space as the time region. Okay, so this is the region of your microscopic atoms and molecules, less than 1 unit of space, which actually is 4.56 times 10 to the minus 8 meters, or 10 to the minus 6 centimeters. Very small, but very large compared to an atom. Same with the cosmic sector. If you don't have a full unit of time, then you don't have time, and you only have space. And so Larson refers to this as the space region. And so the space region is the region of less than 1 unit of time. And 1 unit of time is the inconceivably short 1.52 times 10 to the minus 16 seconds. And when you cross those boundaries, when you cross the boundary from the material sector, in the material sector, when you cross the time region boundary, the rules invert. Okay, so when you are outside the time region boundary, gravitation is an attractional force. It's moving everything inward toward each other. But when you cross that boundary, then gravitation works as a repulsive force. It moves things further away from each other toward unit. So gravitation is always moving toward unit space or toward unit time, whereas the progression is moving away from unit space and away from unit time. But in the time region, that progression is actually a force of attraction. Larson refers to that as cohesion, atomic cohesion. Cohesion is not caused by gravity, it is actually caused by the progression. Okay, I'm guessing that Nehru will probably get into that a little bit more here. According to the discrete unit postulate, less than 1 unit of space does not exist. However, in view of the general reciprocal relation between space and time, an increase of time, say t natural units, is equivalent to a decrease of space of 1 over t natural units. Consequently, we note within unit space, even though the space is constant at unit value, there is a progression of equivalent space. But the magnitude of this equivalent progression is a continuous decrease. 1 over t decreases as t increases, which means that the progression is inward, in contradistinction to its outward progression in the region outside unit space. Since gravitation is a scalar motion, always in opposition to the space-time progression, we find that its scalar direction inside unit space is outward. this manifests to us as a repulsion. In fact, the cohesion between atoms in the solid state is the result of the equilibrium between the inward progression of space-time and this outward motion of gravitation in the region inside unit space. This fact can account for all the types of atomic bonding. There is no necessity to arbitrarily resort to an assortment of explanations like the covalent bond, the ionic bond, the metallic bond, and the like. Larson demonstrates the truth of the underlying theory by calculating solely from it the values of a cohort of properties as interatomic distances, density, the compressibility coefficient, the specific heat, the melting point, etc., of thousands of elements and compounds, and showing their close agreement with experimental values. So, Nehru is saying what I was trying to say, and showing that this kind of equilibrium that's developed between the cohesion or the inward gravitational force toward each other of the progression and the outward gravitational force away from each other in the time region is what is responsible for atomic cohesion, or responsible for what is known as interatomic distance. And in his book, Basic Properties of Matter, Larson uses these relations to determine all of these basic properties of matter and then compare them with the scientific tables that already exist. And in 99% or high 90s% of the cases, he's within 1% of the experimental values, and he goes through that and gives you equations for these different things, compressibility and specific heat and interatomic distance. We'll be going over that book at some point in the near future. This is also pointing out to how he's able to explain all of the different bonding of different atoms with one another in molecules, where the legacy science version of all that is so discombobulated and hard to take seriously, where they've got all these different kinds of bonding, and they still don't cover a lot of different kinds of molecules. So actually, the bonding, chemical bonding, is a serious weak point of the legacy system, and Larson obliterates it. So anyway, I think we're going to leave it there, even though we didn't even cover this whole section that he's doing on gravitation and its relation to chemistry, which is outstanding achievement number 6. He's going to get into, because this cohesion, this occurs mainly in the solid state, and he's going to start talking about the liquid state here a little bit in the next section. Okay, just trying to give you different details and trying to explain. I know that the reciprocal system is super hard to get, and especially if you're already kind of indoctrinated in science as it is, and it's kind of intimidating because it is a theory of everything, and it goes into every subject, and not everybody is an expert on every subject, and so you have to, at a certain point, you have to be able to suspend your disbelief for a little while. You can't just go to these theories with your critical, your critical eye already focused and say, okay, like I'm going to try to figure out a way how to debunk this thing. You know, you first have to be a little bit empathetic and say, okay, I'm going to give this person a chance. Let's see, give this theory a chance. You know, let me take it all in, even though some of it I don't understand, some of it I might disagree with, some of it I learned contradictory theories. Just take it in my head and let it marinate in my head for a while before I discard it. You know, don't discard any of this stuff out of hand, or else you have no chance of learning this. But if you can take it into your head and just kind of let it stay there without judging it, let it sink in, and, you know, kind of, I mean, that's one thing that's really hard about the reciprocal system. And like Dr. Bruce Perret would say, you know, you have to have read about, you know, 5 of Larson's books before it even starts to, you know, you start to see the patterns. You know, a lot of times you can listen to Larson and listen to his theories and be like, oh, you know, well, where's he getting that from? He just seemed to pull that out of his hat. Where's that coming from? But then when you know, you might say that about, you know, his theory of atomic cohesion or whatever, solid cohesion. But then you see that he uses the exact same approach when he's dealing with, you know, planets and galaxies, or, you know, solar systems and galaxies. And then you're like, huh, he's consistent. You know, he's using the same approach. He's using the same principles, and he's getting answers in both of these seemingly disparate fields that your average scientist would say are almost totally unrelated. You know, where he's unifying all of the sciences. But it's very difficult to see it unless you really get the big picture of it. So, you know, at a certain level, you have to just hang in there. And even though, you know, some of these things might fly in your face and you're like, well, that's not how I learned it. I learned it differently than that. You know, where's he getting that from? Just suspend your disbelief for a second and let it wash over you. You got to really get the full perspective before the reciprocal system starts to really make sense. Now, it makes sense on a basic level. You know, the universe is made out of motion, and really when Larson's saying motion, he really just means change. That makes sense. Now, how you can actually turn that into, you know, predicting the instant compounds is much more difficult to get to. Okay, we will take over tomorrow, and have a great day.